Hi everyone. Today we are going to learn how to conduct a dependent t-test using JMP. I'm using the cholesterol data set. And let's say that I want to know if there is a difference between people's cholesterol levels the first time they got it measured, and then maybe a time later, their second measurement. And so notice how the data set, I have the people listed, and then I have, this might be time 1, and this might be time 2. Notice how the data set is set up this way so that we can see that these means are related. I've seen people accidentally do this differently, where they'll have like all the cholesterol level 1s in this column and then continue and then put cholesterol level 2 and then put scores. And so that would be a whole different way of doing that. That would be for an independent t-test. So just remember that when you're doing a dependent t-test, that we're looking at the data by level of student or level of person. And so cholesterol level 1 is matched with cholesterol level 2. And it looks like this person has missing data for the second go around, which is common in collecting data. So first you have to go through your assumptions, and our first assumption is that this is from a random sample of data, that indeed I randomly selected these people. Okay, the second assumption is normal distributions, but here's the trick. The JMP guide, I don't think says this right now as it stands, but you have to find the differences between cholesterol 1 and cholesterol 2. So to do that, you're going to create a column for differences, and you're going to make a formula. So I'm going to put in formula, and then I'm going to subtract cholesterol 2, make a subtraction problem. Cholesterol 2 minus cholesterol 1. And this is going to produce difference scores. So I need to find normal distributions of these difference scores. So I'll go to Analyze, Distribution. I'll put in the difference scores there in the Y column. And I'm going to look for skewness. That is within normal range between -1 and 1. So I don't even have to look at kurtosis. All right, so it looks like that is okay. Now what I need to do, I need to look for homogeneity of variances, and I'm going to look at cholesterol 1 and cholesterol 2. So I'm going to do, how do I do that? Okay, distribution, and then put them both in the Y column. And then remember, I'm going to see if these standard deviations overlap between the two. So this is cholesterol 1, and so somewhere the standard deviation falls between 34 and 45. And then I look over here, all right, standard deviations fall between 35, 29 and 45, 29 and 45. So do those overlap? If I drew some lines, yes, that they do overlap, those numbers do. So there are equal variances here. All right, so what I do to conduct my test, since all my assumptions have been resolved, I go to matched pairs, and I'm going to put in Y, the time 1, time 2, okay? These are paired Y responses. I click OK, and now it's going to show me my t-test. So this is what I report. T parentheses 42, that's my degrees of freedom, into parentheses, space, equals. And then I report the T in -7.16. This is statistically significant because I look at this t-value. I used a two-tailed t-test. And I should have set my alpha before I ran this test. I should have looked at the, I should have looked at the sample size, how many we have here. All right, so my alpha should be at a 0.05 because my sample size is below 250, and I can indeed reject my null hypothesis. And that's pretty much it. And so again, this is what I look at, this p-value. So I reject my null hypothesis, and I would say yes, There are statistically significant differences between cholesterol 2 and cholesterol 1, and that is how you do a dependent t-test. We'll see you next time.